any web page normally is based on a container. Okay, web page contains different objects, and the base HTML file is the container. And normally how it works from a browser, when we place an address, it sends a web page request to the server, and then server sends a reply. And when at the end of the reply the file is attached, so the browser receives the file byte by byte, and then we can actually see the web page. So this is the basic concept of HTTP. Then we have also covered different aspects of HTTP. There are exactly two messages. One is HTTP request, one is HTTP response. And also we have covered about two types of HTTP. One was non-persistent HTTP, and another one was persistent HTTP, right? And then we have also introduced this diagram. As you can see in figure 2.7, we have introduced a measurement of RTT, that is round trip time. That means a small packet going from client to server, and then the respond received from server to client. So this total time of request and response with a small packet is called RTT. This is very important measurement in networking because it gives us a logical time difference instead of the physical distance. So RTT is a measurement about what time it will need to send a small packet to a destination and then receive the response from the destination. So in that sense, for non-persistent HTTP, we have explained it will take one TCP connection, that is one RTT for TCP connection, and then after the TCP is connection is established, then a request will be sent, and then a response will be received, and at the end of the response the file will be attached byte by byte. So the thick line in this diagram, as you can see, represents time to transmit the file. So the larger the file, the thicker will be the line. But again, RTT will be from sending the request until receiving the first few bytes of the response. So for non-persistent, since a new TCP connection must be established before another object can be requested, so it will take 2 RTT plus file transmission time for each object. In case of persistent, the same TCP connection can be used for any number of requests. So that is the idea of non-persistent and persistent. And also we went through the structure of HTTP request message format and HTTP response message format. As you can see in figure 2.8, figure 2.9, this shows the structure of request and response, where the request contains a request line with first there are three components: method, URL, and version number. So first one is method, like we have described some methods in the last class: get, then post, then head, then put. So there are different types of methods for different purpose. And then there is a space, then the path of the URL, then a space, then the version number. Version number can be 1.1, version number can be 1.0. And then there are some header lines. We have already seen some example header lines in the last class. We have described some of them. Each header line has a name, and then a space, and then a corresponding value. And also at the end of each line, 2 special characters indicate the end of line, that is carries return and line feed. and also a blank line with carriage return and line feed will indicate the end of message. Similarly, in the response message, again, there are three parts in the first line, which is called the status line. The first one being the version number, second one is status code, and then third one is status phrase. We have seen some examples of code and phrase like 200, okay, that means successful, 404, file not found. There were some other codes and phrases. And like the HTTP request message, HTTP response message can also use some header lines. The structure is same, header, file, field name, then a space, then the value. And again, the same thing also in response, end of line will be identified by two special characters. One is carriage return, one is line feed, and a blank line with carriage return and line feed would indicate the end of message. And normally, at the end of the response message, the file is attached as raw byte by byte. So I think this is the brief review of what we have covered in the last class. So anybody has any question before we will go to do some exercise hands-on, and then we will go to rest of the topics, that is email and DNS. Any question? Anybody? Okay, if no question, then we will go to do some exercises hands-on. Please keep your pen and paper ready. Please participate and do it yourself. I'll give you some time so it will be easier for you to understand. And by I think in tomorrow's class, I will assign you an assignment that you have to submit in the next week. So if you participate with me in these examples, I think it will be easier to understand. Okay, first one, it says, suppose you needed to use HTTP to download a page with 3 embedded images. Then you have to draw diagrams depicting the main interactions between the client and server when using non-persistent HTTP, persistent HTTP without pipelining, and persistent HTTP with pipelining. So let us do this by hand. Okay, so you have to just draw the diagram. So how many objects are there?
4, sir.
Very good, 4. So 3 embedded images, and then the base HTML. So it will be 4 images. So if we draw the diagrams, let me please do it using pen and paper, and I'll give you 2 minutes just to think and then try. And then when I give the solution, I think you can match your drawing with my solution. Everybody, please draw in your khata or blank paper before I give you the answer. The idea is very simple. For non-persistent, every time you have to create a new TCP connection. But for persistent, with or without pipelining, you create TCP connection one time, and then you can request 4 requests for 4 objects. In case of without pipelining, this will be sequential, like one request for object 1, response for object 1, then request for object 2. Okay, and in case of with pipelining, you can request for object 1, 2, 3, 4 simultaneously without waiting for the response. So that is the idea. Now draw it, and I am giving you the solution. I'm stopping presenting here, and I start. I think sorry. Okay, so you have tried, right? Now let me give you the solution. Okay, so first, if we think about non-persistent, okay? So non-persistent HTTP. This is exercise 1. So this is exercise number 1 and section 2.2. Right now, if I draw the diagram for non-persistent, so I can do it like client. Can you see my screen?
Yes, sir.
Okay.
Yes, sir.
Okay, now let me draw. So first you have to establish a TCP connection, right? So this is for TCP. So that will be 1 RTT. Now for request for HTTP object 1. So this will be HTTP request for object 1, okay, and then response. This is HTTP response, okay, for object 1, and this is again another RTT. Now for object 2, what you have to do again, create a connection
And the request.
right.
Establish connect.
Right. So it will be repeated for 4 times. I am just not showing the file size, okay, because otherwise I have to put a thicker line for each with each response. But you can understand object 1 will be attached with the response. So 1, then this is another RTT, this is another RTT. So each time it will, so this is again for TCP. So this is TCP, this is TCP. Now we have 1 2 object on, so third object, and then another one TCP, and then another one object. So this is now finished. So this is another TCP. So 4 TCP connection. That means now you can see, okay, 1 2. So this is for the first object, this is for object 1 1 2, this is for object 2 1 2, this is for object 3 1, 2. This is for object 4. So what will be, okay, what will be the delay? It is not asked in the question, but let us do it simultaneously, so it will be better for us to understand. So total delay will be what? It will be 2 RTT into 4, right? Plus file transmission time. Okay, so I can write like this: 8 RTT plus file transmission time. This file transmission time will be total time for downloading all 4 files. Is it clear?
Yes, sir.
Okay. Now, if we do it for persistent without pipelining, first do it, because persistent has two subtypes. One is without pipelining. Without pipelining means no new request can be sent before receiving the response for earlier request. Okay, so the same thing what we can do, again client, then server, and then okay, let me do it like this. Okay, so first, in this case also you have to establish a TCP connection, that is 1 RTT. But now the same connection can be used for all the objects, but in this case without pipelining means you have to request and then HTTP request 1, okay, 1, and then HTTP response. This will be also for 1. After only the response you can send another request. After the response you can send another request. After the response you can send another request. So this is what HTTP, persistent HTTP without pipelining. Now how many RTT? RTT, 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 RTT. So this is for TCP and this is for 4 RTT for 4 objects, right? So total delay will be 1 RTT for TCP, right? Plus 4 RTT for 4 objects, and then plus file transmission time. So 5 RTT plus file transmission time. Is it clear? Any question? Okay, now no question. Okay, last one. This is persistent with pipelining. Now with pipelining means actually parallel. Okay, so again let us draw client, server, and now similarly we need 1 TCP, that is 1 RTT for 1 TCP connection, and now we need 1, 2, 3, 4, and then the response. So we can call this like a little more than 1 RTT for 4 objects, and this is TCP one time. So now see, with pipelining you can send all the requests parallelly, but one thing you have to keep in mind, without downloading the HTML file, the client cannot know that there are 4 references, right? So how can we calculate total delay now? We can calculate like this: 1 RTT for the TCP, right? Then plus 1 RTT for base HTML, because you have to first receive the base HTML before browser realizes that there are 3 different image references, right? So plus 1 RTT, this is for 3 image objects. Now this can be almost parallel, this can be a little bit more than RTT, but we can approximate it like 1 RTT, and then plus as previous one, file transmission time. File transmission time will be same in all cases, because that is downloading the total number of bytes of all those files. So that will be same for non-persistent, persistent without pipelining, persistent with pipelining. Any question? Is the answer clear?
Yes, sir.
Okay. Kaushik, are you there? Kaushik Devdas? Khurshida Jahan?
Yes, sir.
Kaushik, are you there?
Yes, sir.
Okay, is it clear? Answer?
Yes, sir.
Okay. Khurshida Jahan? Samir Ahmed? Mahmudul Hassan? Fahim Shakil? Abu Sajjad? Priyabrato? Ali Ahmed?
Yes, sir.
Is it clear?
Yes, sir.
Okay, so Khurshida, Samir, Mahmudul, Fahim, Abu Sajjad, Priyabrato, are you absent or present? I am marking here. If you are present, you should be aware in the whole class. Okay, please be aware, participate. If you are in the class, Priyabrato, your mic is not working. At least you can respond in the message box. Okay. Okay, I want everybody to be alert, because it is for you. Only 2 or 3 of you are responding. All the other persons, there are 57 students in this class. So how can I actually make sure that you all are with me? Otherwise it's of no use. And also, if you participate in the class with exercises, examples, doing with me, I think that will really help you to understand the topic. And 50%, 60% of your concept will be clear in the class. That is better. Only 40%, 30% you have to do at your own. Anyway, so everybody clear? I think this is the main concept of this chapter. And then there are some other exercises. Before that, let me stop presenting here. And now Okay, so if we just want to uh, get a more in-depth concept of HTTP, how HTTP, because you know HTTP is a protocol that enables us to actually request and receive particular content. We click in a file, then the a request is generated and sent to the server. Server responds. But you can assume how many websites are there, right? Hundreds of billions of websites are there. So how all those websites are made available to the users? All uses HTTP. So other than that non-persistent, persistent HTTP, there are some other concepts called content distribution networks. As you can see in the figure 2.26, that is content distribution network, and idea is instead of maintaining a single location of server, they actually distribute the servers, physical servers, in several places. So that's why it is actually accessed by the users efficiently. So like in this diagram, you can see a client using a PC to access, for example, YouTube content or some video content advertised by some company. Okay, so they are actually maintaining their servers in the Amazon cloud, but at the same times they are creating some redundant servers, replicate some servers. Those are called content distribution networks, so that from several parts of the world users can access like this. So they they replicate the same videos, and actually the server should be the files should be downloaded from the server, but it is just the definition is Amazon cloud, but the chunks of different videos are content in the CDN servers. So what happens when a client requests, the request goes to Amazon cloud, or the initial request goes to the Amazon cloud, but then Amazon cloud actually knows in which part of the world their CDN server resides. So they actually send the video chunks. There is a mechanism called dash to the client. So with the help of this, the distribution of contents is actually more and more efficient. So in terms of our case, if we think about this content distribution server, first we have to think about there are not a single physical server that is serving. So far we have assumed all the HTML files, all the image files, all are in a single server, right? Like in the first diagram. See here, we are assuming client is creating a connection to the server, and then client is requesting all the files from the server. So in this case, if we call this a sequential connection, like persistent without pipelining. So in other way, we can call this a sequential single connection. If that is the case, then if there are 10 objects, each object will be served separately. So request for first object will be sent, then the response will be received, then request for the second, because there is a one single connection. So 10 objects will need 10 different request response. So that is one case. But we can also think about parallel concurrent connection. In parallel connection, like if you can create 3 parallel connections, that means 3 connections will be used parallelly. So for example, if you need to download like n files, those n files will be served using 3 parallel connections. If you say, okay, n parallel connections are possible, then each object will be sent parallelly. So this is another case. In case of parallel, definitely it will take much less time. We will do some exercise on this. So there are, how many combinations are there? See, 3 parameters. You can see here 3 parameters. One is whether or not the objects are within a original server or within content distribution server. First parameter. Second parameter is whether the connection is sequential or parallel. And the third parameter, I think we have already saw some examples, that is non-persistent or persistent. So based on these 3, we can also think about this figure in the bottom one, like client is creating a connection with the original server, and then client is also creating a connection to the CDN server, because they are 2 different physical servers. Now, having said that, each connection can be sequential or parallel, and maybe this physical server is original server is actually in USA, so there is a long distance also in terms of time. But maybe the content distribution server is in Bangladesh, or is in Singapore, or is in India. In some cases, it is globally, it is geographically closer to the client's device. So in that case, its RTT will be different. So see, for the first case, RTT, we don't know which RTT is larger, which RTT is actually a smaller value, but it should be different. And also each connection can be sequential or parallel. So based on this, let me do another example, that is exercise 3. Exercise 2, you can do it yourself, because we have already shown you how to calculate the time delay. Now exercise 3 says we would like to download an article on the web. This involves 2 steps. So it just says the procedure of downloading. Normally this procedure actually works every time we browse internet, we download something. Step 1, you have to download a master index file. When you click google.com, which file comes? Anyone, any idea? You click facebook.com, because we are not specifying any particular file. So there is a index file. When you, if you have some idea about web development, when you develop a website, these are actually collection of pages, and out of those web pages, one page, normally it is index.html, is defined as the master index file page. So when you just write down the domain name www.google.com, then Google has a master index file. If you write like facebook.com, Facebook has a master index page. So sometimes we don't give the file name itself, but it refers to the master index file. Then after downloading the master index file, then we actually go through, click different links, and then for each link, I think there is a file specified, right? So the first step is download that master index file. We assume the size of the file is B, and then this page contains like 4 images. And then in the step 2, see, the important matter is the browser must download the index file first, that is HTML file first. Then browser can discover, okay, there are 4 other image references. So you cannot do it at first, like download 5 files at the same time. You have to download the master index file first, then you will download the 4 other images. Okay, and then based on this, you have to answer some questions. Okay, so let us do some of this. Ignore all transmission delays, just to make it simple. Those transmission delays means the file transmission delay. We are just ignoring, because as we said, file transmission delay will be same for all cases. So for the simplicity, we ignore those transmission delays. Assume that, but in your question, having said that, in your question, if it is specified that the link capacity is, for example, 5 Mbps, and your total file size is, for example, 9 Mbps, definitely you can find the file transmission time by dividing file size by the capacity. We have already seen some examples, right? So if that information is given in your question, you can also find out the transmission delays, no problem. But for this question, we just assume, we ignore the transmission delays. Assume that HTTP response fit in a single TCP packet. These are actually, even if I don't specify this in the question, you can assume this, because we know the application layer data is divided into a number of TCP packets, and each TCP segment adds its own header. So if we assume more than one TCP segment, then it will be more calculation. So for simplicity, again, we assume the HTTP message is very small, so it actually fits in a single TCP segment. So one HTTP response will be in one TCP segment. We don't need to wait for the HTTP responses to be acknowledged, nor for the TCP connection to terminate. So we are not worried about when the TCP connection is broken, or we are not worried about when the HTTP response about the feedback or acknowledgement. So these are all simplifications. Now calculate the time taken to download the article under each of the following scenarios. The article has what's the size? The master index file is B, and each of the 4 images are also B. Okay, now you have to calculate the time, but we are not worried about the size. We are worried about the RTT, how much RTT will be needed. Okay, A, first case A, all files are stored at a single origin server. S, our RTT to S is R. That means we use sequential requests with non-persistent TCP connection. So out of those 3 parameters, we have to actually decide. We have to use, for question A, we have to use non-persistent, and we are assuming all files in the single server, and since all files are in a single server, RTT is R for all cases. So what will be the delay? So how many files here? 4, right? How many objects? 4 objects. For non-persistent, we know 2 RTT for each object. Okay, so the first answer will be very simple. What will be the delay? 4
Sir,
into
object কি পাচ্ছি না?
Sorry, object, oh sorry, total 5, right, total 5, right. 4 images plus 1 master, total 5. So the first one will be very simple, 5 into 2 RTT, right?
Yes, sir.
Plus file transmission time, but it will actually depend. Okay, let us do this in a text file. For example, today is our 7th class. Okay, so let me just see what is here. No, this is not. Okay, these are all previous files. So okay, fine. I think we can open this. This is our 7th lecture, right? So 7th lecture. This is Sunday, and today is 21st March. I am just renaming my earlier trimester's file. Okay, so that was actually, we have covered lecture 6. That was on previous week, Sunday, 14th March 2021. It is not makeup class, it was regular class. Okay, so we have This we have already reviewed. So exercise 3. Now we are in exercise 3. Okay. Let me not doing all this before. And also we will do, okay, so we will do this later. Okay, so first question, what will be the delay? 5 into 2 R. R means the RTT, and then plus file transmission time. Although this question asks you to ignore the transmission delay. Again, I am clearing you that in the question I may ask you to also calculate the transmission delay. So in our case, in that case, we need the transmission rate, but there is no transmission rate given, right? The file size is given, but there is no transmission rate given here. Only RTT is given. So that's why we can just write file transmission time, or we can just omit this. So 5 into 2R, that is 10R. Or better, if we write this like this way. See what I said. The client must download the master index page before it can actually request for other images. So you can directly 2R, because you know all the files in the same server, and you know there are 5 objects. But if you divide this in this format, that will be better to understand all other cases. First, it needs to download the master index file, so it needs 2 RTT, and then for each of the object, each of the image, it needs 2 RTT. So 4 into 2 RTT, that means 10R plus FTT. Clear? Actually, this is very simple, but for the next cases, you have to actually understand this. Any question in answer A? Okay. Now, if you think, in question B, it is said, again, all files are stored in a single origin server, our RTT R. We use sequential requests with persistent TCP connection. So that means now it is persistent, and also we use sequential request. Sequential request means what? Without pipelining, right?
Yes, sir.
Without pipelining. So without pipelining means, now how you can calculate this? You can calculate this like, sorry, delay will be, now we will do in this way. Okay, we will do in this way. So all the files in the original server, that means 2R master index page will be same, right? No change. Why 2R? Anybody? Why 2R? Nibirujjaman, please let me see who are awake, not in sleep. Nibirujjaman, are you there?
বাট আমার নেটের অনেক সমস্যা হচ্ছে তো স্যার, মানে ঠিকমতো ক্লিয়ার হইতে পারিনি।
Okay, you are not clear. Okay, fine. Sadman?
Yes, sir.
Can you tell me why it is 2R, 2 RTT for master index page?
No, sir, I can't understand properly.
But you are not asking me. I am just going and going. You are not asking me. Adnan Kabir? Adnan? Taki Yasir?
Sir, I cannot understand.
Taki?
Yes, sir. Hello?
But you cannot understand, right?
Sir. Yes, sir.
Shahadat?
Yes, sir.
Can you tell me
Yes, sir.
why
Sir.
it's 2R? Okay, tell me.
One for TCP connection, one and another for
Request and response. Very good.
requests.
Very simple, very simple. Just you have to be awake in the class. say 57 students in the class. How can I, every time I ask everyone? That is a problem. So please, I am marked, those I didn't find awake, I marked absent. And for today, they will not get attendance even if they present themselves later on. Because I know there are many problems you are facing, so many problems with network. Even I am also facing problems, but it should not be like that. I am just logged in the class and then I am not anymore. I saw this is a problem in our online class. So I will try to find you awake. If you don't understand, no problem. But see, I asked, I think 5 or 6. Everybody said I don't understand. But when I go carry on, nobody is asking any question. Those who are replying, because I know I repeat same thing many times. And for some of the students who are very serious, sometimes this might be boring because they understand the concept very much. But again, I am repeating and repeating. Why? For the other students. But at least I should, I think, expect some cooperation from you. It's only for you, not for me. Anyways, please try to participate as much as you can. That will help you. Okay, so it is actually very simple. From the first example, I am saying the same thing. In persistent, one TCP will be used for all objects. In non-persistent, every request will need a separate TCP connection. But the reason why I have separated the answers into two parts, one is master index and one is other objects, because irrespective of non-persistent and persistent, if I say 2R, 2RTT for master index page, that accommodates both non-persistent and persistent, right? So in case of B, for persistent, I have already considered the TCP and the request for master index, request and response. So for the rest of the objects, rest of the 4 images, I don't need any TCP connection, right? So that's why what will be the change here? 4 into R. Is it clear?
Yes, sir.
Yes, sir.
Okay. If you understand the concept, okay, what is the change here? See, in my earlier drawing, what we did, one TCP is required for persistent. In question B, what it says, persistent, right? So we will need one TCP connection. Now here, in twice R, twice RTT, right? Already one TCP connection is considered. So for the rest of the request responses, we need no more TCP connection, right? Agreed?
Yes, sir.
Yes, because TCP connection already, once TCP connection established, that is already considered in master index. So for the rest of the request responses, we don't need, in persistent, we don't need any more TCP connection. So only we need request and response. That is one RTT for one object, right? So there are 4 images, so 4 into R. That means total is 6R plus FTT. Clear, everybody?
Yes, sir. Yeah.
Okay. I think if we forward, I actually will not solve every question because some of these you can try and you will find, I think, easy. Let me do C, do it yourself, because it says concurrent requests with non-persistent TCP connections. Okay, I think I have to show you this because it is concurrent. So concurrent means what? Parallel. Now, how many connections you can create? That is another question. Is it specified in the question? Question C, how many connections you can create? It says concurrent requests. That means parallel connection. But how many connections? Is it clear in the question? Is it specified?
No, sir.
Yes or no? No. So if there is no information about how many connections are there, that means what? That means you can theoretically assume any number of parallel connections you can create. But I could have changed this question like 2 parallel connections fixed. Doesn't matter how many objects are there. Then you can use only 2 parallel connections. So total delay, you can just divide by 2. Okay. But when it says, when it does not specify any particular number of parallel connections, then you definitely will, you can assume theoretically any number of connections can be created. So there are 5 objects. So you can assume I can create 5 different parallel connections. Fine. But again, keep in mind, master index file must be downloaded first, right? So you cannot create 5 separate connections right away. You first must need to download master index file. Then you can create concurrent download for the other images. So 4 parallel connections, right? Is it clear at this point?
Yes, sir.
So in that case, what will be the delay? Now we are using concurrent with what? With non-persistent, not persistent. It is non-persistent with concurrent. So again, first part will remain same, right? Now for each of the 4 images, what is the size of each image? Is it same for all? The file size. See, all the file has size B, right? So all images are of same size? Yes or no?
Yes, sir.
Yes, same size. It says size B. All images are same size. So if all images are same size and RTT is same, that means if I create 4 parallel connections, each one will take how much time in non-persistent? 2 into R, right?
Yes, sir. 20.
Yes, sir.
Clear. Every connection will require twice R. And since all connections are parallel, what will be the total time? 8R or twice R?
Twice, sir.
Twice, sir.
Twice R, because all are parallel. So see the difference. If you can create parallel connections, definitely time will be less. So even if that is non-persistent, see, it will take 4R, right? Okay. Now, if I change the question, I'll not do the rest of the questions. You should do those questions, and then we'll discuss in the next class again. Because I have already shown you all possible combinations: persistent, non-persistent, parallel, and sequential. One other combination is origin server or a separate server. Okay, I'll show you one more example. But in this question, if I change just non-persistent to persistent, what will be the change in the answer? Right? In question C, only I will change this part. Instead of non-persistent, it will be the just persistent. Then what will be the change?
So there will be one TCP request for all the 4 images.
Right, but that is already here. That is already here. So in this case, what will be?
It will be 1
R,
R.
right?
So
Right.
one.
Only R. 1 R.
Yes, sir.
Right. It will be only 1 R. Clear? Because no more TCP connection is needed. Only each object should be requested, but parallelly. So that's why each connection will require 1 R. So all 4 connections will require 1 R because all are parallel. So this will be the change. Now, the last combination of not only original server, using some other content distribution server. Question number D. The content provider now signs up with a content. They actually rents or contacts with some other company who gives content delivery network service. They say, okay, I have my physical servers placed here. So if you want, you can use my server to advertise your content or to store your content so that your customers can get that. That is the idea. Now, this content delivery network will store different objects of those websites or web pages. Now, what it says, the master index page, it is still served from the original server. So they want the user will first log in or go to their main server, but then the other files should be downloaded from closest other CDN server. So it will reduce the load on the original server, number one. Number two, for downloading other files, the client will take less time. So these are advantageous, and this is how internet actually works so efficiently. But in our case, now instead of original server, some files will be stored in content delivery server, and definitely the RTT will be different because these are two different servers. So the original server RTT is same as R, and the closest CDN server will be R/2. And then sequential requests with non-persistent TCP connections. Now find the answer. So sequential, non-persistent, and there will be two servers. Did you get the point?
Yes.
Now, what will be our change in the answer? Again, twice R will be same, right? Because the master index file still needs to be downloaded from the original server.
Yes,
Okay. Now the second part. So see, all 4 images are in the CDN, and it uses sequential. Sequential means one connection at a time. That means it is what? Non-persistent, right? Non-persistent. So it will be 4, but in this case, it will be R/2, right? Because all 4 images, sorry, it will be 2 into 4 into
R/2.
2 into R/2, right? This 2 into R/2 means
4 hours.
each object, right? Each object will be requested to the CDN server. CDN server has RTT R/2. This is just a RTT actually, R/2. And since for every object, it needs to create a TCP connection. That means it will be 2 into R/2 for one object. And there are 4 objects, so it will be 4 into 2 into R/2. Is it clear?
Yes.
So if you just complete the calculation, it will, this 2 will be cancelled out. So it will be 6R plus FTT. Okay, now rest of the part you should do it yourself, and then I want you to face some problems and then ask me in the class. And tomorrow I will give you one assignment that you have to submit in the next week. So that is actually end of the examples. These already we have discussed in the last class. I think you can try to solve these too, and then if we have problems we can discuss in tomorrow's
Sir,
class.
I have a
Tomorrow we will make
question.
Sure.
Sir, what if like if there are 4 images and each one of it has a different file size, is it gonna be different? Or
Yes. Good question. Actually, that's why for simplicity we have assumed ignoring transmission delay. But if you want to calculate the transmission delay, then if RTT is not different, then our answers will be same. That will not make any difference. Okay. If RTT depends only on the logical distance between client and server. So it does not depend on what? File size. It does not depend on file size, right? So since this question ignores the file transmission delay. That's why even if files are of different size, that will make no difference. But if you need to find out the file transmission time too, then okay, no problem. You just even if the file sizes are different, you just sum up all the file sizes, right? And then in that case, you have to get a transmission rate from the question. There is no transmission rate given in this question, right? For example,
Sir.
let me make it clear. In the knowledge test 2, I think at the end, there is another question, similar question. That will be probably in your homework. Similar question. Now see, it is not saying ignore transmission delay. It gives you all the information like web page 7 kilobits, each image is 2.5 kilobits, and definitely it gives you a capacity, that is transmission rate, right? So can you calculate the delay now, file transmission time? Yes or no? File size divided by capacity. What is that? File transmission time. So file transmission time equals to actually file size by capacity. So even if file sizes are different, you sum up the total file size and
Yes.
you divide by the
capacity.
given, right, by the capacity. So you'll get the delay. No problem. Clear?
Yes, thank you.
Okay. So when you will go with yourself to solve the rest of the question, definitely you will find something. If I give the total solution, you cannot find those problems. So that's why I want you to solve yourself and then come up with, if not tomorrow, come up with the questions on our next class on Wednesday, so that we can better discuss about the possible problems. So I will end the HTTP part here, and then in the last part of our lecture, we will actually continue with our other protocols, other two protocols, that is email and DNS. Okay. So our second protocol in this chapter will study. This is not protocol. This is email system. Actually, email system uses some protocols. We all used emails, and we used web-based emails. So we are very much connected with the emails. Just we need to have a better understanding about the underlying principles or protocols that email uses. First of all, email has three components. One is called user agent. User agent means the software that user uses to compose and send an email. Like in our case, what is the user agent? Most of the cases,
It's your
we
browser.
use, right, our browser, HTTP protocol that we use to connect to our Gmail server or Yahoo server. Okay, so that's user. But there are some standalone softwares, you know, Eudora, and in Linux there are some like Pine, and then Microsoft Outlook. Those are also user agents, right? Yes, there are so many. Then second one is mail server. Mail server is a physical email server that actually works to transfer the email to the correct destination. And each mail server, as you can see in the diagram, each mail server has two components. One is you can see the green one, that is the message queue. That is a queue where the messages are first stored, and then the yellow boxes, these are mail boxes. And each user, when we register in with an email server, they create a mailbox with some space with my name. So finally, the emails are stored in those mailboxes, and then as a user, we access those mailboxes to read the mails. Okay. And the third component definitely is the protocol. Without protocol, nothing will work in networking. So the main protocol is simple mail transfer protocol, that is SMTP. This is mainly to forward the mail from user agent to the user's mail server to the destination mail server. These are forwarding protocol, SMTP. But there are mail access protocols, like what we have just mentioned a little before, we use HTTP for mail accessing, right? Mostly now because of its usefulness. But there are also some other protocols like IMAP, Internet Mail Access Protocol, like POP, Post Office Protocol. Those are mail access protocols. The third component is generally protocol. So user agent, mail server, protocol. As I said, user agent is the mail reader. It can also be called as mail reader. It enables us to compose, edit, and read mail messages. In our case, that is using browser. But in other cases, you can use Microsoft Outlook. There are different softwares for iPhone. And then user agent mainly, what's the main function of user agent? Outgoing, incoming messages stored on the server to transfer. Now, mail server. So mail server, as I said, two components. One is mailbox that contains the incoming messages for user, and one is message queue. When we click send, I send a message to another person that first goes to the message queue of the mail server that I am connected to. And last one is the SMTP protocol that actually enables mail server to forward the mail to the recipient's mail server. And in this case, both are mail server, the receiver, sender's mail server and receiver's mail server. But in this case, the sender's mail server, we can call it a client, and the receiver's mail server is called a server. Okay? Any question?
No, sir.
Okay. And definitely we can find some similarities of email with other protocols like HTTP. Like we said, HTTP uses TCP. Email also uses TCP. Basically, SMTP uses TCP. HTTP uses port number 80. Email uses port number 25. Then there is a concept called direct transfer. Sending server acts as clients. Since both are servers, who will be client, who will be server? Because it is a client-server architecture. So sending server acts as a client to the receiving server. And direct transfer means there is no intermediate mail server between sending mail server and receiving mail server. Suppose I am sending a mail to my friend. My email address is abc@gmail.com, and my friend's email address is xyz@yahoo.com, right? So definitely my friend is connected to Yahoo mail server, and I am connected to Gmail server. So when I send a mail to abc@yahoo.com, definitely it will first go to my mail server, Gmail server, and then Gmail server will directly send to Yahoo server. There will be no intermediate mail server in between. So that is called direct transfer. And for transferring, there are three phases. One is handshaking, like since it uses TCP, so it's a reliable protocol. Transfer of messages, then close the connection, same as HTTP. And also similar to HTTP, all the commands are ASCII text. ASCII text means these are human readable. If you read the headers of any email sent, you can actually be able to read the contents. And then definitely there are responses, some status code and phrase, and all messages must be 7-bit ASCII, as I said. Now, how this works, very simple example. Every time we send an email, these 6 steps are what is being done. So first, in this case, Alice is sending a mail to Bob, and Bob's address is bob@sameschool.edu. So step 2, whenever Alice composes the mail and clicks send, then Alice's user agent sends the mail to the mail server, and mail server first stores that in the mail server's message queue. Then it says, okay, the destination is sameschool.edu. So that is definitely a mail server. So Alice's mail server now opens a TCP connection with Bob's mail server, and then send the mail to the message to the Bob's mail server. Bob's mail server will definitely contain a mailbox because Bob is a registered user of Bob's mail server. So step 5, Bob's mail server places the message to the Bob's mailbox. Bob's mail server cannot ensure the message to go to the user agent because the user agent PC may be offline. It depends on when Bob goes online. So when up to this point, step 5, SMTP can work, forwarding the mail. But when the mail is inside the Bob's mailbox, it is Bob's responsibility to log in and then receive the mails. So this is the last part. Bob inbox is user agent to read the message. And this is not SMTP protocol. This will actually use some other protocols. We'll see. But SMTP is the mail forwarding protocol. And SMTP has some similarity to the HTTP. As I said, it uses TCP. It's a client-server architecture. It uses 7-bit ASCII code. But it has some differences to the HTTP also, because HTTP is called a pull protocol. SMTP is called a push protocol. See why? In case of HTTP, we request a file. So as a client, it pulls the document from the server, right? In case of SMTP, just in the earlier slide, what we said, direct transfer, sending server acts as a client. So there are two servers, sending server will be client, receiving server will be server. So in
Sir.
case of, yes.
So what's the full form of RFC?
Oh, okay. RFC is request for comments. As I said, I think in the earlier lecture, all these publicly available protocols has defined documents, maybe hundreds of pages. And suppose you want to develop a browser, new browser from your own in any language, then definitely to make your browser working with others, you must follow the HTTP protocol, right? Then where you get the HTTP protocol? You just search in Google. You can get some RFC number. Every protocol has a corresponding number, and this document is available publicly in the online. So you just download the document, you go through the document, what to do, what needs to maintain, then you create your own browser so that it will be compatible with others. Otherwise, it might not work. Okay, so every protocol will have a corresponding document starting with RFC. RFC means request for comments. SMTP is a push protocol because now the client pushes the resource, because see, the sending server pushes the message to the receiving server. So it is called a push protocol. So you have to understand the logic, not only the word. So that's why SMTP is SMTP is push protocol. HTTP or FTP, those kind of protocols are pull protocol. But both have ASCII commands. And another difference is HTTP can send only one object at the end of the message. But SMTP can, as we can attach multiple files with email, right?
Yes, sir.
So SMTP can contain multiple images, multiple attached files. So in that case, SMTP creates multiple objects with each one with a separate message. But in case of HTTP, you can never attach multiple objects at the same HTTP reply. Okay, so that is another difference. These are the main differences. Some other small differences here. Just go through that yourself. And mail access protocols. As you can see in the last part, when the receiver's email server puts the message in the receiver's mailbox, then it is the receiver's responsibility to access to the mailbox. Like in our real case, peon puts the letter in our post box. Maybe that is locked with some that is locked, and then when we go and then open the box, then we get our letter, right? So similarly, user needs to access, and SMTP will not work there because SMTP requires both sides must be on. Since receiver may be offline when the message is received, so that's why it uses some access protocols, that is IMAP or HTTP or POP for mail access. Now the basic differences is for mail access protocols. There is one called POP, Post Office Protocol, POP and IMAP both needs to be configured in the desktop. So that is one advantage of using HTTP, because you just need the internet connection. You don't need to configure to access to your email from anywhere in the world, whether you are at home, whether you're at office, whether you're at airport, anywhere in the world. If you have just the internet connectivity, you can check your mail. But if you want to use POP or IMAP, that must be configured at your desktop or at your machine. But sometimes this is useful because that may be customized according to your requirements. And then normally POP works in client-side manipulation way, like
Sir,
whatever you do. Sorry. Yes.
sir, POP like works in like working companies, right? Like, you know, like people work over there and everything.
Sorry. Ask the question again.
No, sir, I mean like POP like works as in like with working companies, I think, like in offices.
Oh, okay, right.
Yes,
In especially, yes, right, POP and IMAP, this type of things, because even Microsoft Outlook, because these are more like you have more control, and you have everything at your hand. Okay. And also, if you configure in your local network, if you want your local network employees to exchange mails using the system, even in that case, you may not have the internet connectivity. Okay. But
Sir,
if you want
আমাদের
to, yes,
অ্যান্ড্রয়েড অ্যাপের ইমেল প্ল্যানগুলো তো হয় পপ অথবা আইম্যাপ দিয়ে মেলটা স্টোর করে রাখে।
right. There is option even in Microsoft Outlook, especially in organizational environment, they use this. And even when you take internet connectivity from service provider, you can ask IMAP or POP configuration from them. So it's based on your requirement. But why HTTP is most popular among people? Because of that point, you just need the connectivity. You don't need to configure anything. And other basic differences between POP, IMAP, and HTTP is POP is client based. That means whatever you do, the manipulation will be at your desktop. So if you do something in your desktop, like if you created a directory, you just stored some mail there, you go to your office, you will not get that. That is the problem, right? So IMAP somehow solved that, because in IMAP it first says all manipulations will be in the server. What is the advantage? From my home, I did something in the server, I go to my office, if IMAP is also configured there, then I can get the same view. But definitely IMAP must be configured there. In case of HTTP, you don't need any configuration. That is the main advantage. And also because it is a web page, so it gives you a web interface. So that's why the underlying configuration details is managed by the company. Gmail takes your input, and then Gmail does the underlying email things under the cover. So that is, for the end user, that is advantageous. And also you can see some RFC numbers here. See, IMAP, Internet Mail Access Protocol, RFC 3501. So if you search with RFC 3501 in the Google, you will get the complete document about IMAP. And in IMAP, the main idea is retrieval from server, messages stored on server. And what is the advantage? So from anywhere, since all the manipulations are in the server, if I can access the server, I can get the same view. Clear? So this is about the mail access protocol. I think I cannot start DNS today, so DNS will cover on tomorrow. That is end of email. So the last protocol will start tomorrow. Any question, anybody? If not, please let me take the attendance. Abdullah Al Rifat.
Yes, sir.
Enamul Haq.
Present, sir.
Imam Reza.
Present, sir.
Okay. Rukunuzzaman Khan. Rukunuzzaman. Laila Ishrat.
Yes, sir.
Farah Farzana.
Yes, sir.
Fazle Rabbi,
Yes, sir.
Ifat Haq Rafsan,
Yes, sir.
Ali Ahmed,
Yes, sir.
Shahadat present, Rakibul Islam,
Yes, sir.
Al Shahriar,
Yes, sir.
Tanvir Hassan,
Yes, sir.
Shakib Hussain, Mashuk Alam,
Yes, sir. Sakib Hossain, sir.
Yes, sir.
Shakib
Mashuke Alam.
okay, Mashuke Alam, Sabbir Sarkar,
Yes, sir.
Abrar Sadiq,
Yes, sir.
Ishtiaq Ahmed,
Present, sir.
Abdullah Al Mufail,
Yes, sir.
Mahfuzur Rahman Sifat,
Yes, sir.
Shafiqul Islam Nirob,
Yes, sir.
Amanta Hussain,
Present, sir.
Abir Reza,
Present, sir.
Khondokar Jahidul Islam, Khalid Ridwan,
Yes, sir.
Shahariaz Rimon, Tahmina Tanjin,
Present, sir.
Muhammad Mahfuzur Rahman,
Yes, sir.
Fazila Nobi present, Ashrafun Nahar,
Present, sir.
Shifa Chaudhuri,
Yes, sir.
Misbahul Alam,
Yes, sir.
Yasir Arafat,
Present, sir.
Sudeep Sarkar,
Present, sir.
Abdur Rahim,
Present, sir.
Miraz Farooq,
Yes, sir.
Abu Abdullah, Khondokar শ্রাবণ Ahmed, Shah Alam,
Yes, sir.
Imtiaz Hussain,
Present, sir.
Rifat, Imtiaz present,
Yes, sir.
okay, Rifaz Nahian,
Yes, sir.
Kamrul Islam Tushar, Dihan Pathan,
Present, sir.
Abu Kibriya,
Yes, sir.
Bidhan Chandra, and Shakhawat Hussain.
Present, sir.
Okay, Shakhawat present.
স্যার সামিয়া আমার প্রেজেন্ট ছিল
স্যার ডিসকানেক্ট
Sir.
হয়ে গেছে, আমি অ্যাটেন্ডেন্সটা দিতে পারিনি।
Sir.
Yes,
Tatoki Yasir to present, sir. That number.
Taqi Yasir present, right?
নিবিরুজ্জামান
Those who I called earlier already given. Okay.
Sir,
Yes.
sir, Bidhan Chandra Das present, sir. Maybe problem হচ্ছে like chat
Okay.
chat
Okay.
স্যার